I'm looking at the worksheet, how to work combined gas law problems. That should be what's labeled in Google Classroom. It looks like this if you have the hard copy of it. And the process is really pretty straightforward. Write the givens, write the equation, write the numbers in the equation, draw a box around your answer. Stuff that we've done before. Now here's where it's really, really important. When it says write the givens, when you have multiple givens, you want to make sure that you've written them down so you have them listed out and you know what is what. So I have the equation written here if you want it in fraction form, and I have it written here if you prefer it out of fraction. So either one is okay. I'm going to use this one up at the top here. And when you do this, that means when you write things down, you have to make sure that you get the T1s and the T2s, the P1s and the V1s, and the P2s and V2s. You have to make sure they're 1s and 2s. Generally speaking, the 1s go together. They're written in the problems together. The 2s go together. But understand what the question is asking you. It's the volume of this particular gas, and it'll give you a pressure for that. So they link them together in the problem. All right. So there are a couple of things it says up here. First of all, change your temperatures to Kelvin. Always, always, always change the temperatures to Kelvin. And in this piece of information right here is really important too. If the problem says something stays constant or it doesn't say anything at all about it, that particular variable, whether it's pressure, volume, temperature, number of moles, you can cross it off in your equation. So we can totally ignore it. So I'm going to look at the first one here, and it says the volume of the lungs is measured by the volume of air inhaled or exhaled. If the volume of lungs is 2.400 liters, and I labeled that for you as V1, during the exhalation, and the pressure is 101.70 kilopascals, notice it's the volume and the pressure, and they're together. These are the ones. And the pressure during inhalation is 101.01 kilopascals. What's the volume of the lungs during inhalation? So they've kind of split it up into exhaling and inhaling. I've bolded these for you just on this first page so you can kind of figure out what's going on, but it's a really good idea to go through and circle your numbers. Don't forget to circle the unit of measurement along with it right here, and then your unknown. So your first step, it says write the givens. If you print your paper off, it doesn't matter. You need a separate sheet of paper and you can put your stuff in here. So number one, I'm just going to write the equation up here first. My equation is P1V1 T2N2 equals P2V2 T1N1. Now, I don't have all that stuff in there. So when I look at my problem, does it say anything at all in here about temperature? Well, it doesn't. That means we assume the temperature stays the same. I can knock it out of my equation. Does it say anything in here at all about number of moles? Well, it has nothing in there. So we don't have to worry about those. So my equation now becomes P1V1 equals P2V2. Now I can write my givens here. Now I kind of swap numbers 1 and 2 around, just depends on how I'm working at it, but I'm going to write the givens. So here I've got V1 and P1. So I'm going to put P1, I'm just going to make a list, V1, P2, V2. Well, P1 is 101.70 kilopascals. V1 is 2.400 liters. P2, 101.01 kilopascals. And V2, that's what we don't know. So I've got the equation, I have my givens, I have the equation, now I need the numbers in the equation. Leave yourself enough space. I write kind of small, so I've got enough space here. You guys need to make sure maybe you want to put your givens way over to the other side here, but you need to leave yourself enough space because that information right here takes up a lot of space. So I'm going to drop back down here, and it makes me happy to write it all again. P1V1 equals P2V2. So if I look at this, I've got P1, and that's 101.70 kPa. And I've got V1, 2.400 liters. I have P2, 101.01 kPa. Times, and here's my x, or my unknown. If it helps, what you might want to do is put your units of measurement in a different color, kPa. liter kPa. And that way you know those aren't variables, those are just units of measurement. And that way you're not worried about, well, what is that? Is my X? Was that? What is that? I don't know. Because you've got a lot of variables, P, V, N, R, T, all, and all those things are in here. So now what I can do is I can solve for my X right here. So you have your calculator, grab your calculator, and when I put it in my calculator, I've got 101.7, I'm going to open my parentheses, 101.7 times 2.4, close parentheses, and I'm going to divide out on each side. These two things are multiplied together, so I'm going to divide out. If I divide it by one side, I have to do the same thing on the other side of the equal sign. So it's divided by 101.01 kilopascals. And I've got this ugly answer. Is that okay to have an answer like that? I don't know. Let's plug it into our calculator again to be sure. Let's make sure I did this right. So 101.7 times 2.4, and I didn't put parentheses, so I'm going to put enter here. And then it's going to be divided by 101.01. There. Looks like I punched them in wrong my first time around. Okay? So my new liters, because it's asking me for V2, right? I've got 2.416 liters equals V2. Now, let's look at that a second. Does it make sense? Well, let's see. My pressure, did it go up or down? Well, my pressure went down, right? And that means my volume went up. Okay, what I'd like you to do is pause this a minute and go get an index card, or what I did is I just got a scratched piece of paper and cut it into a little square here. So pause this and go get an index card or a scratched piece of paper. Now that you have that, what I want you to do is I want you to write in the lower left-hand corner P, in the middle I want you to put T, and over here on the far right-hand side I want you to put V. And this is a really cool little thing that you can use because it's comparing pressure, temperature, and volume. So if you hold one of these constant, let's say I'm going to hold temperature constant. When I hold the temperature constant, I don't let it change. And when I hold the temperature constant and I increase the pressure, the volume goes down. And that makes sense. If you squeeze it, you increase the pressure, then it's going to make it take up less volume. If I hold the temperature constant and I decrease the pressure, then the volume goes up. So when I decrease the pressure, they spread out more. And then they take up a lot more volume. If I hold the volume constant, then if I increase the temperature, if you guys can see that, if I increase the temperature, the pressure also goes up. If I decrease the temperature, and I'm just doing this, if you look at the card, I'm going up, moving the card up and down like this. So if I increase the temperature, the pressure also goes up with it. If I decrease the temperature, the pressure also goes down with it. So if you hold your thumb over one thing that you're maintaining constant, hold the card flat. If you raise up the temperature, the volume also raises up. If you decrease the temperature, the volume also goes down. But notice the pressure has to be constant. If you don't hold one of these constant, then you can't, it doesn't really help you at all. So this is a really handy thing. So when I look back to my problem, my pressure 1 was 101.7, now it's 101.0. So my pressure went down. My temperature, I don't even have temperature in here, so my temperature is constant. When my pressure goes down, the volume goes up. As my pressure went down, the volume went from 2.40 to 2.41. So we know we're on the right track here. So put a box around your answer, and there's your answer to that. If I look at number 2, the total volume of a soda is 415 mils. Of this 415 mils, there's 60 mils of headspace. Okay, we're not doing liquid problems, we're doing gas problems. So we don't care if we have our soda can over here. We don't care about the liquid in here at all. We're not doing problems with liquids. 60 mils is the headspace. So this is 60 mils of the gas that's in there, right? So that's why that's our V2. Of this 415 mils, there's 60 mils of V2 of headspace for the CO2 gas put in to carbonate the beverage. If a volume of 100 mils of gas at STP, that's 1 atmosphere, is added to the can, what's the pressure if the can has been sealed? Okay, so, and this is, sometimes the problems can get kind of messy in here and thinking, oh, what, is that V2 or P1? It doesn't matter what you call the ones and what you call the twos, as long as they're together. So if you look at these right here, here's our can, they've got the volume in here, and they're going to insert 100 more mils of gas at this pressure. So this volume and this pressure go together. If a volume of 100 mils of gas at STP, there it is right there. So that's why these two are linked together. Again, you can call these ones or you can call these twos, it doesn't matter. So what's the pressure? So now what I'm going to do is I'm going to come back up here to the top and I'm going to write my big equation one more time. P1 V1 T2 N2 equals P2 V2 T1 N1. So when I look at my question on number 2, they didn't say anything at all about number of moles or temperature. So my equation for this is P1 V1 equals P2 V2. So drop down here to number 2, and P1 V1 equals P2 V2. Okay, I like to write the equations on these first because that helps me to figure out, okay, what are all my givens? So I've got P1 V1, P2 V2. So when I look at my problem here, I've got 60 mils as V2, and I've got 100 mils as V1, and I have 1 atmosphere as P1. And if you look at this, what's the pressure in the can when it's been sealed? And you can see the reason I called this V2. So after it's been sealed up, they want to know the new pressure. So here's our original pressure. Oh, well, never mind. So anyway, you've got your setup here. And so now, I like to write it out. And I'm going to go over to the middle of my paper, and that gives me plenty of space. And don't be afraid to write crap down. It's not going to take you an eternity of time to write this out. So I'm going to go, my volume 1 was 100 mils. My pressure 1 is 1 atmosphere. My pressure 2, I don't know. And my volume 2, so I'm just filling these in. Now, typically I'm going to say, hey, I have to have my volume in liters, but these milliliters, since they're both in milliliters and they're both going to cancel out, I really don't need to take that extra step and change it. Typically, again, it's in liters, but in this particular case, when we do these, we don't have to always change them. So here's my unknown. So what I'm going to do is these two things are multiplied together, so I'm going to divide out the 60 mils. If I do it to one side, I have to do it to the other. And what cancels out? Oh, look, I see a milliliter and a milliliter. They cancel out. So when I pop this into my calculator again, I've got 1 times 100 is 100, so 100 divided by 60, and I've got 1.667. 1.667 what? Well, we're trying to find pressure, and our pressure is measured in atmospheres, so here's where we have it. And then we can look at our card and say, let's see if this makes sense. I kept the temperature constant, and our volume, right? Our volume, hang on, let me get this over here. Let's see, volume, where am I here? Our volume actually decreased, right? So our pressure went up because we're putting more, kind of think of it like this, we're putting more stuff in a smaller space. So we're basically increasing the pressure, And so our volume went down in that sense. Okay, so on each of these, this is what you're doing here. If it says STP, then STP tells you two pieces of information. It tells you the temperature, which is 0 degrees Celsius, and if you multiply by 0, it's going to screw everything up, isn't it? So you have to change the temperature to Kelvin. And our pressure, when we have STP, is 1 atmosphere. So when you look at this, this is what you need to keep in mind. You need to practice on these questions, and if you have questions, you need to make sure that you message me. You can message me on Remind, or you can send a note to me on the papers that are in the Google Classroom.